And now, the way we, of course, learn things here is I teach you definitions, theorems, postulates, and they allow you to set up equations, and then you can solve for unknowns. And that's your algebra portion. Okay, so let's read this. Kj and Km are opposite rays. Okay, so they're all collinear, forming a straight line. Kn bisects JKL. Well, I like to add tick marks to my picture. When I have words here, I like to put that information in the picture. One arc mark on each means that those two angles are congruent, and we know that by definition of an angle bisector. Okay, JKN equals 8x minus 13, and NKL equals 6x plus 11. So we take a little time, write tick marks, and information in our picture. Again, it's a bisector, and we know by the definition that it creates congruent angles, therefore angles equal in measure. Okay, so we know that 6x plus 11 equals 8x minus 13. We can go ahead and solve this. Subtract 6x. Add 13. Divide by 2. Okay, so x equals 12. Now, if this were a multiple choice question, this would be one of the possible choices for your answer. But if you chose 12, you would be incorrect, because the question wasn't, what is the value of x? The question was to find JKN. So now we have to find the measure of angle JKN equaled 8x minus 13, which equals 8 times, substitute this in, minus 13, 96, minus 13, 83. And we could check our answer by seeing if we plugged in that 12 in here, if we also got an 83. So 6 times 12 plus 11. 6 times 12, 72. 72 plus 11, 83. It checked. Now I've added this. This is not on your handout. I would like you to find the measure of LKM. We know this is 83 degrees. We know that this is 83 degrees. We're trying to find this angle here. And now I haven't taught this just yet, but many of you probably know. What's the measure of this right here? That straight line. The measure of angle JKM, that straight line, equals 180. So now we can use our angle addition postulate. 83 plus 83 plus the measure of angle LKM equals 180 degrees. 166 plus the measure of angle LKM equals 180. Subtract 166 from both sides. The measure of angle LKM equals 14 degrees. Okay. All right, now we're going to talk about naming and classifying pairs of angles. And you'll notice this is not on your handout. You're going to have to get a piece of notebook paper and copy this down. And then we will go to the handout. All right, so first thing we want to do is talk about the definition of adjacent angles. So again, on a piece of notebook paper, the definition of adjacent angles. They are two angles that have a common side, have a common vertex, lie in the same plane, and have no interior points in common. Now you can always pause the video and get all that written down. Okay, let's take a look at some examples of adjacent angles, or an example anyway. Angles 1 and 2 are adjacent. They have a common side right there. They have a common vertex right here. They're in the same plane, and they do not overlap. Sometimes it's easier to understand what something is by looking at what it's not. Okay. Angle A, OC, and angle A, OB. They have a common side, OC. Here's AOC, and here's AOB. So they have a common side, OA. I said OC before, that was a mistake. They have a common side, OA, right here. So we're talking about this angle and this angle. They have a common vertex right there, and they lie in the same plane. However, these points are in both angle AOB and AOC, so they have common interior points. Therefore, these are not adjacent angles. These are not adjacent angles. Which of the four does this break? They do not have a common vertex. Therefore, they're not adjacent angles. Imagine if I had a rectangular prism here, and I looked at this angle here, and this angle here. They have a common side right there. That's the common side. They have a common vertex. They don't share any points in common, but they are not in the same plane. So these are non-examples. This is our example, okay?